In warfare, there are moments when the balance of power shifts, not through diplomacy or politics.
They say the next great war won't be fought just with bombs or bullets. It'll be fought with speed. And now, America may finally have a weapon fast enough to change the game. A new missile, one that could end the hypersonics race, is emerging from the shadows. It's called the Angry Tortoise, and it might be the United States' only hope for catching up with China and Russia in the race for next-generation hypersonic power. This could be America's first true hypersonic missile. A weapon with a unique liquid engine, one that's accurate, maneuverable, and fast enough to outrun anything our adversaries can throw at us. The U.S. has been trailing behind in the global hypersonics arms race. Both China and Russia reportedly have multiple operational hypersonic weapons already in service. According to a recent congressional report, some of these systems might even carry nuclear warheads. For years, it seemed like America had no real answer, but that may finally be about to change. At a military conference just last month, the Air Force Research Laboratory, the AFLRL, unveiled something unexpected: a new lower-cost hypersonic missile project known as the Angry Tortoise. The first test launch is scheduled for this December. According to Nils Sedano, a technical advisor for the AFLRL, the project's name is a playful jab at the Air Force's own struggles to keep up in the international hypersonics race. He reportedly told Aviation Week that the Tortoise might finally catch up. So what makes this weapon so different? Let's take a step back. Hypersonic weapons are defined as vehicles or missiles that can travel at Mach 5 or faster. That's 5 times the speed of sound. At those speeds, distance becomes meaningless. A missile traveling that fast could cross 1,000 miles in just 10 minutes. They're not just incredibly fast, they're also hard to detect, difficult to intercept, and potentially devastating. China's growing hypersonic arsenal, for example, has already raised serious alarm in Washington. Reports suggest that some of Beijing's hypersonic missiles could destroy as many as 10 U.S. aircraft carriers within the first 20 minutes of a conflict in the South China Sea. If that claim is even partly true, it represents a major strategic challenge for American forces in the Pacific. For now, no true hypersonic weapon has been used in combat. Russia's President Vladimir Putin has claimed that the country's Kinzhal missile, deployed in Ukraine, can maneuver at speeds above Mach 5, but many experts believe that's an exaggeration. There's an important distinction here. Some weapons are technically hypersonic simply because they travel faster than Mach 5, but true hypersonics can also maneuver freely at those speeds, changing direction mid-flight in meaningful ways, not just minor course corrections. And by that definition, the Kinzhal doesn't really qualify. Nothing more than an air-launched ballistic missile. Jeffrey Lewis, Ph.D., of the James Martin Center for Non-Proliferation Studies in Metairie, California, told Popular Mechanics in 2023, "It's only hypersonic in the sense that pretty much all ballistic missiles are hypersonic." By contrast, America's Angry Tortoise aims to meet the true definition of a hypersonic weapon, and it's doing it with the help of a revolutionary new engine. That engine is called Draper, designed by a Colorado-based aerospace company called Ursa Major. It's a 4,000-pound thrust liquid-fueled engine that combines the best features of both solid and liquid propulsion systems. This is a big deal. Liquid-fueled engines are generally more maneuverable. They can throttle up or down or even restart in mid-flight. That flexibility makes them much harder to intercept. But traditional liquid fuels are highly corrosive, unstable, and can't be stored long-term. A major logistical headache for the military. Ursa Major's new Draper engine solves that. It uses a propellant mix of hydrogen peroxide and kerosene, a blend that's far less volatile. It can be stored safely at room temperature for long periods, yet still delivers the raw power and responsiveness needed for hypersonic flight. This means missiles like the Angry Tortoise could be kept ready to launch at a moment's notice, something that used to be nearly impossible for liquid systems. And there's another breakthrough. Because Draper is a liquid system, it can be reignited multiple times. Solid-fueled engines, once ignited, can't be stopped. They burn until they're empty. That's a major limitation for most missile designs. Draper's reignition capability opens the door for reusable test vehicles and potentially even multiple-phase hypersonic systems that can maneuver, re-enter, or adjust flight paths mid-mission. Draper's design isn't starting from scratch either. It's built on the foundation of another Ursa Major engine known as Hadley, which previously achieved sustained hypersonic speeds. Like Hadley, the new Draper engine is made primarily using 3D printing. Roughly 60% of its parts are printed. This makes it significantly cheaper and faster to produce than traditional rocket engines, which require months of machining and assembly. It's a smart move, reducing cost and development time, both of which have crippled past U.S. hypersonic projects. And that history hasn't been pretty. In recent years, several American hypersonic programs have faced major setbacks. The Air Force's Air-Launched Rapid Response Weapon, or ARRW, developed by Lockheed Martin, failed more than half of its early test launches and was eventually put on hold. Another program, the Hypersonic Air-Launched Offensive Anti-Surface Weapon, also from LEAD, was supposed to become America's next advanced anti-ship missile, but it never got the funding it needed and was ultimately cut due to budget constraints. The Angry Tortoise aims to break that cycle. It's not just another prototype. It's a technological demonstration built to prove that hypersonic systems can be developed faster, cheaper, and smarter. And the big first test for Angry Tortoise is set for December at the U.S. Army's White Sands Missile Range in New Mexico. That's the same historic site where America tested its first atomic bomb back in 1945. But this time, the focus will be on speed, precision, and engineering. During this initial test, the missile isn't expected to reach full hypersonic speeds. It'll likely max out around Mach 2. That's about 1,535 miles per hour, or twice the speed of sound. The limitation isn't with the missile, but with the range itself. White Sands is simply not large enough to handle the flight path of a full hypersonic test. At Mach 5 and beyond, the missile would leave the range boundaries in seconds. That's why Ursa Major already has plans for a longer-range test over the Pacific Ocean in 2026. According to the War Zone, that test will allow Angry Tortoise to stretch its wings and finally show what it's really capable of. For now, it's important to understand what Angry Tortoise actually is and what it's not. It's not yet a fully operational weapon. It's a demonstration, a scientific and technological project designed to push the limits of what's possible. But if it works, it could completely reshape America's hypersonic strategy. In just 3 years, the Draper engine has evolved from a concept on paper into a test-ready system. That kind of rapid turnaround is virtually unheard of in military aerospace development. If the upcoming test is successful, it could signal a new era for how the U.S. approaches advanced weapon design, one built on innovation, efficiency, and adaptability. The question is, will it deliver? The United States has a long list of hypersonic programs that started with promise and ended in disappointment. For every success story, there has been a cancellation, a delay, or a budget cut. So all eyes are now on this one small missile, the so-called Angry Tortoise, to see if it can finally give America the edge it's been missing. If it performs as expected, it could become the foundation for a whole new class of hypersonic weapons, ones that are affordable, reliable, and built for the realities of modern warfare. Or it might just join the graveyard of failed hypersonic dreams. Either way, this test marks a turning point. For the first time in years, there's genuine momentum, a sense that the U.S. might not just be reacting to China and Russia, but finally innovating its way back to the front of the race. When we talk about hypersonic technology, it's not just about who can go faster. It's about who can control that speed. Who can design a weapon that's not only blindingly fast, but also intelligent, maneuverable, and precise. That's the holy grail of modern missile technology. And that's exactly what the angry tortoise represents. A cautious, calculated step forward. It's slower than a hare, but it might just win the race. Because in the world of hypersonics, every fraction of a second counts. And right now, America is racing against time. This is an interesting question that a lot of military analysts are looking at: hypersonic weapons. Now remember, there is a sort of a race to get the hypersonic weapons. Now these are weapons that are said to be faster, stealthier, and, in many cases, even unstoppable. The Russians and the Chinese appear to have a bit of an edge over the Americans. You heard that right. Despite the technological superiority that the United States claims, this is one field where China, Russia have a clear edge over the Americans. United States of America now hypersonic missile systems may disrupt the delicate strategic balance of power between the nuclear states. Hypersonic missiles are basically projectiles that can move at a speed of at least about 5 Mach. That is 5 times the speed of sound. But this is about 1.7 kilometers per second, or 6,174 kilometers per hour. In warfare, there are moments when the balance of power shifts, not through diplomacy or politics, but through technology. Moments when the rules change. Today, one of those moments. After years of testing, setbacks, and speculation, the United States has unveiled what it calls its first true hypersonic missile. A weapon designed to travel at more than 5 times the speed of sound, to maneuver at the edge of the atmosphere, and to strike targets before an adversary can react. It's a development that could redefine modern deterrence and mark America's long-awaited answer to the hypersonic advances of China and Russia. Cut to visuals, missile launch tests, engineers, satellite imagery. For decades, speed has been a constant pursuit in warfare. From the jet age to intercontinental missiles. But hypersonic weapons are something different. They promise not only extreme velocity but unpredictable flight paths and the ability to evade the most sophisticated missile defenses ever built. At these speeds, Mach 5, Mach 10 and beyond, a weapon can cross hundreds of miles in minutes. The question is no longer whether it can reach the target, but whether anything can stop it. For the United States, the path to hypersonic capability has been long and difficult. Early experiments date back to the 1960s when researchers explored high-speed flight at the edge of space. But real progress began in the 2000s under the concept of conventional prompt global strike. The idea of being able to hit any target on Earth in under an hour with a conventional non-nuclear weapon. That vision required new materials, new propulsion, and new guidance systems. It also required billions of dollars and patience. Meanwhile, Russia and China pressed ahead. Moscow showcased its Avangard glide vehicle and the Zircon anti-ship missile. Beijing revealed the DF-17 capable of carrying a hypersonic glide vehicle of its own. Both nations signaled that they were not only testing such systems, but fielding them. Suddenly, Washington found itself playing catch-up, an unfamiliar position for a country long regarded as the world's technological leader in weapons development. That is why the U.S. announcement matters. The system now approaching operational readiness is the result of years of joint effort between the U.S. Army and the U.S. Navy. A weapon family based on a common hypersonic glide body launched by different boosters from land and sea. The Army calls its version the Long-Range Hypersonic Weapon, or LRHW. The Navy refers to its counterpart as the Conventional Prompt Strike System. They share the same warhead, same glide vehicle, and same purpose: to deliver a precision strike at hypersonic speed. When launched, the missile's booster rockets ignite and propel the vehicle high into the upper atmosphere. At a precise moment, the glide body separates, coasting at hypersonic velocity, more than a mile per second, toward its target. Unlike a traditional ballistic missile, it doesn't follow a predictable arc. Instead, it can change direction and altitude, skipping along the edge of space before diving down in its final approach. That maneuverability makes it extraordinarily hard to track or intercept. For defenders, the window to react is measured in seconds. Recent U.S. test data suggests the system can reach speeds of Mach 5 or greater, with ranges extending over 1,000 miles depending on the configuration or critical infrastructure. The first operational Army battery is expected to be fielded by the end of 2025, marking the first time an American hypersonic missile will move from the test range into active service. For the Navy, the progress has been equally significant. At Cape Canaveral, engineers recently conducted a successful sea-based launch using a cold gas ejection system to safely expel the missile before booster ignition, a critical step for submarine deployment. When fully integrated, this capability would allow U.S. submarines or surface vessels to launch hypersonic missiles from beneath the waves or beyond the horizon, striking targets at tremendous range and speed. It's an ability that few nations can claim. But this unveiling is not just a technical achievement. It's a strategic signal. For years, the narrative has been that the U.S. was behind in the hypersonic race. Russia claimed operational systems as early as 2018. China followed with public parades and flight footage of its DF-17. Western analysts warned that America's deterrence edge was eroding. Now, with the LRHW entering service and the Navy system close behind, Washington is effectively saying the race is far from over, and the United States intends to lead again. The strategic rationale is clear. Hypersonic weapons fit into a broader shift in U.S. defense posture, away from counterinsurgency operations and toward high-end competition with peer adversaries. These weapons are meant to give commanders the ability to strike quickly in highly contested environments, where slower cruise missiles or traditional air power might be vulnerable. In a future conflict, speed could be the deciding factor. The side that strikes first, accurately and unpredictably, gains a decisive advantage. Yet, the path to this point has not been easy. Between 2010 and 2022, the United States conducted more than 20 publicly acknowledged hypersonic tests. Roughly half of them failed. Each test meant millions of dollars in hardware destroyed in seconds and months of analysis to determine what went wrong. Heat shielding, control systems, and guidance electronics all face immense challenges at hypersonic velocities where temperatures exceed 2,000 degrees Celsius, and air itself becomes a plasma that interferes with communications. But gradually, through persistence and investment, the U.S. programs began to mature. The LRW uses advanced composite materials designed to withstand those extreme conditions. Its guidance system combines inertial navigation with satellite assistance, ensuring accuracy even under electronic attack. And its launch platform, a mobile transporter erector launcher, allows the system to move quickly, set up, fire, and relocate, reducing vulnerability to enemy preemptive strikes. Still, analysts caution against overconfidence. Speed alone does not win wars. Intelligence, precision, coordination, and decision-making matter even more when timelines shrink from hours to minutes. A hypersonic strike capability is only as effective as the information guiding it. That's why the U.S. is pairing these weapons with investments in satellite networks, artificial intelligence, and real-time command systems to ensure that when a target is identified, a strike can be ordered and executed within seconds. Looking forward, the story of hypersonic weapons is still being written. Beyond the LRHW and Navy variants, the Air Force is developing its own projects, such as the Hypersonic Attack Cruise Missile, a smaller air-launched weapon designed for fighters and bombers. Each service is experimenting with new propulsion systems, scramjets, and materials that could make hypersonic flight more efficient and affordable. Over the next decade, we can expect hypersonic technology to evolve rapidly, not only in offensive missiles, but in defenses designed to counter them. Because even as the United States fields its first operational system, another race has already begun. The race to detect, track, and defeat hypersonic threats. New radar systems, space-based sensors, and interceptor missiles are being developed to respond in seconds rather than minutes. The same innovation that fuels offensive hypersonics will inevitably drive the creation of defenses against them. History shows that every breakthrough in military technology eventually meets its countermeasure. So what does the unveiling of America's first true hypersonic missile really mean? It's more than a new weapon. It's a statement about strategy, innovation, and intent. It demonstrates that after years of testing and catching up, the U.S. has reached a turning point from research to readiness, from prototype to deployment. It shows allies that American industry and science can still deliver under pressure. And it signals to rivals that the technological playing field is once again contested. As this new generation of weapons enters service, the balance of power will not shift overnight, but it will shift. Every nation will adapt, plan, and calculate differently, knowing that distances no longer guarantee safety and time no longer guarantees warning. Hypersonic missiles compress not just space, but decision-making itself. They make war faster, riskier, and more uncertain. And that is perhaps their most profound effect. In the end, technology is only as decisive as the strategy behind it. The United States' first true hypersonic missile represents the fusion of decades of research, billions in investment, and a clear signal of intent to ensure that no potential adversary gains a decisive advantage in speed, reach, or precision. The era of hypersonic deterrence has begun. An era defined not by who can build the biggest arsenal, but by who can think, decide, and act the fastest.